So the age-old question, we have all this data, what do we do with it now? What can we do with it now? It's great that we can get the scanner and we can go out and we can collect all this information, but what do we do with it? Well, let's first look at what's in a point cloud. If we were to go out and survey a site, we would go out and collect individual locations of various components of the site, such as the locations of individual utility features or of planimetric details. When we go out and we scan, we're collecting every piece of information that's there. Now, this information can be overwhelming. If we look at the example here, we have tons of data. We can see the existing utility lines. If I go into a little bit more of a perspective here, we can see the overhead traffic lights. We can see the locations of each of the utilities and all of the signage and all of the data that's here. How can we make something of this? Inside a program for handling point clouds, I can do things like remove noise from the tin. So where we have vehicles passing by, I can take the vehicles and remove the vehicles and the noise out of the scan, being left with just the data that I'm interested in, such as the pavement locations, the sidewalk locations, the utility locations, so on and so forth. Now, inside these programs, I can also do functions like create meshes. So if I were to take this scan, clean it the way I want it, I could create a mesh. I could export that mesh as a DXF into AutoCAD, or I could even create a point list for using inside a program like Civil 3D or Carlson to generate a surface inside of their program. So from that perspective, the data is useful. But let's say I just want planimetric detail. Let's say, for example, on this particular site, what I'm interested in is only the information in this area of the site. And what I want from this is I want the line work. I want the information like the back of curb locations, the edge of pavement locations, so on and so forth. So what I could do is I could go into this scan, I could isolate down the area that I'm interested in, and what I can do here is I can tell it, you know what, I don't want to deal with this whole thing. I'm dealing with, just tens of millions of points. I want to focus on one area, so I'm going to take one area, copy it out, and just begin looking at that data. Now, what I can do is a couple of things. For example, I can flip this around in a perspective, and I could come in and say, okay, here's what I'm interested in here, is this edge of pavement line that runs right along here. So I get it where I can see it, and then I can come in and start picking points and saying, okay, just as if I had surveyed this, just as if I had walked out here and said, we're going to start picking up points here, here, and here, take these points and let's create a polyline from those points that I just picked. Okay. Now, I could also automate this process a little bit. If we look at the other side of the street, I can come in where I have a good section of curb, and I'll zoom in on this area, and what I will tell it is that within this area, I'm interested in extracting the curb. So I'm going to pick a point, and then I'm going to define essentially a template here. So I would fit edge, and it analyzes the data and says, here's what we found. I'm going to delete what it tells me the template should be, and I'm going to flip this in a view so I can see it. And then I'm going to come back in and say, well, what I'm interested in is from this point to this point to this point, and then out to this point. But what I want to extract from here is the back of curb, the flow line, and the edge of pavement. I'll tell it to fit. It'll analyze the data that's there, and then I can shrink or grow the line work that it gives me. Once I'm satisfied with it, I can tell it to go ahead and create. Now, I'm looking at this in a very simplistic form. I'm looking at just a small section of the site, just showing some of the things that we could do with this. Now, let's take our sign here, for example. If I zoom into that sign area, we could use a function, for example, here in Cyclone called Virtual Surveyor. And what Virtual Surveyor would allow me to do is to create an ASCII file, the same thing I would do if I were surveying. What I'm going to do is pick locations, assign a code, it writes a point number, a northing, an easting, an elevation, a description, and the code, and then stores that in an ASCII file, which I could then import into Civil 3D, Eagle Point, Carlson, Microsurvey, any program. So one of the advantages here of the point cloud, as opposed to just a traditional survey, with a traditional survey, I only get what I collect. So if I miss a manhole, or I miss a sign, or maybe I labeled something, I'm not sure what it is, I want to go back and look at it, the advantage of the scan is I get everything. I can then go back and start extracting out pieces of information that I want. Now, everything I've done so far has been done in Cyclone. As I mentioned in the post, there are other programs out there for extracting this information out, and different skill sets and different scenarios will call for use of those. I'll talk about one here in just a few minutes that Leica has as an add-on to AutoCAD called CloudWorks. By using CloudWorks, I have the advantage of not using the tools available in Cyclone, but having the tools available in CloudWorks as well as my traditional AutoCAD tools. Microsurvey has a point cloud program. Carlson Software has a point cloud program. Even Civil 3D has point cloud capabilities. So there are becoming more and more options and programs and commands available to deal with this data and to extract out the pieces of information you need. These are just a couple. So let me go ahead and finish with Virtual Surveyor. So I'm going to call this... well, we'll just use the file that I have here, the H275. So I'll open that file and I'm going to overwrite whatever data is there. Okay, and what happens is I'm given the Virtual Surveyor program. Okay, what I'm going to do is I'm going to use just a generic code library, whatever's here. If I had a custom library that I was using, maybe it matches my field codes, I could use that as well. Okay, what I'm going to do for my first point is I'm going to create a code called sign, and I'm going to use my little zoom focus, and I'm going to come in to the location of this sign. Okay, and then what I'm going to do is I am going to use my pick point, and I'm going to set the point right there. So that's point number 1, that's my sign. I can come out and find another sign and repeat that process. But I'm going to say that that's my only sign, so we'll go ahead and check that in and say that point is good. What I then want to do is come over here and let's look at some of the functions like the pavement or my sidewalk. So I'm going to say edge of pavement. I'm going to use a multi-pick, and I'm going to say, starting right here, these points represent my edge of pavement. Okay, again, I'll check those in, lock those in, we've collected those, we're good. Now what I want to do is I'm going to do some sidewalk points. Again, I'll use my multi-pick and I'll walk down the sidewalk. Now, as with anything else, how well you scan this and how clear the scan is dictates how good this data is going to be. If my focus is that, hey, I just want rough planimetric data, that's all I'm going to focus on. I don't have to worry about getting good detailed scan to pull all of this out. If my focus is on topography, I want to create 2-foot contour map, I would collect the scan just like I would my topo with a total station or robot or GPS. Focus on what my end result is going to be. I'll check that sidewalk section in, and then I'll create another code called sidewalk 1, and I'll repeat the multi-pick and I'll get the other side of the sidewalk. My survey rules apply just as they would if this were my total station. I'll check those in, and we've got all of our points in. Everything looks good there. What I want to do is I want to output this in 5 columns. I want it to be comma delimited, and I want this to be in US survey feet. Column 1 is the point number. Column 2 is the northing. Column 3 is the easting. Column 4 is the Z value or the elevation. You could go either way with that. And then column 5 is that feature code. I'll save that output. So now we have an ASCII file of the points. That's one way we can get data out. Okay. If I close this viewport, I'm going to tell it not to save. I'm not worried about the data that we created here. Because I already created a couple of the lines using those same functions. And what I want to do is I want to turn my point cloud off so that all I'm looking at are the polylines that were drawn. And what I want to do with these is I want to select all. And what I want to do is export these as an AutoCAD DXF file. Okay, I'm going to call it line work, and I'm going to overwrite the file that's already there. I want everything selected and everything visible. Now, if I wanted the point cloud, I could take the point cloud over as well. That's a lot of data to deal with in AutoCAD, and unless I have a program like CloudWorks or Carlson Point Clouds or Microsurvey Point Clouds, I don't know that I would just dump a whole cloud into CAD. But we brought those files in, so let's open our LineWork DXF file. We'll zoom extents, and so now first things first, we can see all of the line work that we drew. Okay, now I want to import the ASCII file. So from points, let's set a coordinate file, and we're going to call it points from cloud. And what we'll do is we'll import that ASCII file. There's my file. There are my points. It's a point number, northing, easting, elevation, description format. We're going to skip the header line, and let's go ahead and bring that guy in. There were 16 points created. Those have been brought in. I'm using Carlson Survey here, and now we'll tell it to draw field to finish. My code table is the same code table I use for everything else I do. So my same rules apply. My sidewalk, existing, sidewalk. I'll make the color yellow, and I'll tell it to draw 3D polylines. And then I'll add one more code for my sign. And then I'll pick my symbol. So if I had a special code I was using for different types of signs, I could use those codes. Okay, so my codes are there. I'll tell it to draw those, draw all points. And then just like that, the codes that we told it to draw were placed in. Now I can use my other functions here, so I could triangulate and contour from the data that's there. Let's go ahead and set a TIN file. I could go over to the selection and tell it to process an external ASCII file. My file happens to be easting, northing, elevation, so I change that. I'll tell it yes, go ahead and overwrite my existing file. I have no inclusion, no exclusion. I'll window around the points and break lines. I'll then grab my grid file that I created in Cyclone. I want to use all points in that file. And just like that, we've created a surface using the mesh data that was over inside of Cyclone. So we'll come in and look at it, and then we can see what my surface looks like. There's some areas that still need to be gone back and looked at and cleaned up a little bit, break lines that need to be added. But for the most part, that's just a quick, down and dirty, simple way I can move data from a program like Cyclone into AutoCAD and begin using it. And then, like I said, there are other programs. There's CloudWorks. You have Carlson Point Clouds. You have Microsurvey Point Clouds. Civil 3D has capability. There are a lot of ways you can begin extracting information from the point clouds.